It's time to build a turntable setup for our robot. So, let's grab our gray and chrome balls, our Macbeth chart, and create this turntable macro all together. First, what is a macro? If you're familiar with Nuke, you can think of a macro as like a gizmo. It's a group that wraps around a single node or a group of nodes, and we publish them so that their state is saved and can be recalled in other projects later. You can expose controls from certain nodes on the group itself. While you can add user parameters to any nodes, they are particularly useful in groups and macros, where user parameters on the parent node can drive parameters on child nodes hidden inside the group. It's important to know which parameters would be beneficial for our artists to have control over. In our turntable macro, we wanted to control the visibility of the color checker scene, the ability to swap cameras easily, the option of changing the asset path, and loading the project file automatically. Let's hover over the wrench icon and select Edit User Parameter. Side note: at this point, we simply add our custom parameters, and we will then connect them to our child nodes afterwards. One step at a time. We are being patient and hardworking here. Under User Parameter, click Add Number. A new user parameter of type number is created. Change the widget type of your user parameter to checkbox. This is useful if you need to toggle on and off something inside your group, as we will need to. We will rename this user parameter to Color Checker Visibility, as we will want our artists to have the ability to toggle on and off the visibility of their color check assets. We will keep adding controls to our group. Under User Parameter, click Add String. We will rename our widget to Camera Path. How will we bring our camera path here? Well, we'll change the widget type to Scene Graph Location. We will also want to have an easy way to swap our asset quickly. So we will reproduce the same steps for the asset path. Let's go a step further and create a new user parameter and set it up to group. We will rename the new parameter to File Path. Then, we will add a string and set its widget type to File Path. Every time we will need to call upon our project directory, we will refer to our group level to access the project directory. Now, time to go connect our upper level to nodes inside the group. But we have no nodes inside the group yet. No problem. We will start with an alembic in to bring our Macbeth chart and our chrome and matte spheres. We will start by using the expression equal /user, which is referencing the upper level of the group node, to bring our assets into the stage. Once the color checker asset is imported into the scene, we will need to find a way to smooth it, turn its shadows off, and add a control on its visibility. As you probably remember from the first video, we can achieve this by using our normal object settings node. On the parameters, we will click on geometry.smoothing, subdivision surfaces.subdive, type Cat Clark, iterations 2, turn off shading receive shadows and self shadows, and finally add an expression to control the visibility. We can step out of the group quickly to verify if our expression is working. Is the check mark inside Null Toggle done? The same as outside? Yes, it is. It means that we did it. Once our assets are loaded properly, as we can see it in the viewer and in the scene graph, we need to apply materials to our assets. We know how to do this by now, don't we? Yes, we do, with the NetworkMaterialCreate node. As we have 3 objects with 3 different shaders, we will add 3 network materials on our NMC. We can keep it straightforward for our materials. Inside the NMC, we will be creating 3 standard surfaces and playing with the settings of each of them to obtain the expected result. The matte shader will have a base color gray at 0.18, the diffuse roughness at 0.3, the specular transmission set at 0, and the surface scattering at 1.6. For the chrome material, we will set the base color to 1 and the metalness to 1, while we keep the specular at 0. The texture file for the Macbeth chart will also need to be imported and plug into its own standard surface. So we will add an image shader and connect it to the base color of our last shader. Then, once that is done, we can rename our NMC to match our network material, which is Chrome, Matte, and Macbeth chart. We can connect our shaders to the corresponding materials, and there it's completed. Let's merge those materials with our color check assets. With a material assign node, let's do a quick assignment to each asset, and there we have a shaded color checker ready to be used for all our future models we will bring into our template. We now need to build a little stage for our turntable to take place. We are still showing a star. Let's import a backdrop and floor to be ready to roll. I will go over this part in fast forward because there is nothing new to learn in this section. It's basically a copy-paste of what we just did. And boom, the ground asset is in the house. We can merge those 2 branches again, specify our render camera with a render settings node. Then we can merge our scene with the look dev scene we just created. Let's have a quick look through the viewer. And yes, there it is. Our scene is built. Let's add a DollyConstraint to our scene. A DollyConstraint ensures that the target fits exactly in the camera screen window and is useful especially for turntable setup, where we want the asset to always be framed perfectly. For the base path, we will refer to our camera path that we exposed on the group level, and for the target path, we will refer to the asset path. For positioning the color check assets, we will be using a parent-child constraint to keep our asset snug in the lower corner. If you are wondering what is a parent-child constraint, well, it applies a constraint that translates the base object to a point defined by the target object. So we will specify the camera path in the target path. The color check assets will then always stay in the frame, never missing a viewing, unless if the visibility is turned off voluntarily. Maybe we would like to position our color checker a little better, so we will add a Transform 3D node to fix those last-minute placements. We will try to position the color checker in the left bottom corner of our viewer. Whenever we are adding constraints, it is a good habit to add a ConstraintResolve node to make sure all constraints will get resolved at render time. Time for our turntable grand finale, making our asset turn 360 degrees for the first 50 frames of our scene. Let's add another Transform 3D node, call the asset path on our group, and go on the y-axis of the rotation. We can use Python to create simple expressions in Katana. If the frame range is greater than 0, but smaller than 50, rotate for 360 degrees divided by those 50 frames. Now that our macro is completed with the LookDev scene built inside, we will add it to the other regular nodes in the Tab Node Creation menu. How can we add it to the other nodes under Tab? Simply by clicking on the wrench icon and clicking on Save as Macro. We can send some preview renders at different frames and with various variations to see how our asset is reacting. It seems that we're getting a positive response. And voila! We just created a macro with controls, turning our setup into a reusable group that can be used for any models. That is how we nail the turntable setup in Katana. If you found this helpful, we have tons of other tutorials on our Learning Foundry page. Until next time, happy rendering!